Okay, this is a little awkward to do this way, but I want to show you what's actually happening in terms of voltage changes across the membrane and also permeability changes. So literally some of the passage of specific ions across the membrane as this process of the action potential proceeds. So look at this particular overhead, and along this axis right here, this is actually showing you which ions are actually flowing, like how many, sodium ions or potassium ions, for example, are going across the membrane during the time of an action potential. This is the time course along here, starting from the zero line here and heading this direction. This is in milliseconds, so this is a very fast process in action potential. This is literally, thousandths of a second. So the entire process of an action potential is typically over, within 4 milliseconds. So that's, very, very fast. So this axis over here, actually the opposite side, is actually showing you the membrane potential, the potential difference, right? The difference in charge inside versus out. So if we start at time 0 and we look at the V line, this is the voltage or the potential difference, right? It starts at around minus 65, right? Minus 70. It starts at the resting potential, right? And then I want you to notice something. The V line starts to go this direction. It starts to go from minus 65 to minus 60 to minus 55. It is depolarizing it. Something is depolarizing it. I'm going to give you an example in a minute, but it can be many things that can depolarize a neuron, from its resting potential of minus 65 towards the threshold potential, remember, of minus 55. So at minus 55, I want you to see what happens. All of a sudden at minus 55, this voltage line really shoots up, right? It goes way up here. In fact, it goes all the way to positive 20. Now let's see why. So at minus 55, at the time of minus 55, if you look at this line below that's also peaking in this way, this says G Na. This is the conductance of sodium. This is a measure of how many sodium ions are moving, right? And remember, the sodium ions are going to start moving across the membrane at minus 55 because those voltage-gated sodium channels will open, right, for about a millisecond, right, at minus 55, right? Then they'll shut, right, because all that sodium is rushed inside, and now it's changed the structure, the conformation of that voltage-gated sodium channel again and put it into its second sort of closed form. Well, as you have all that positive sodium rushing inside, right, the voltage line continues its rise, continues to get further and further depolarized. In fact, it reverses polarization, right, becomes positive on the inside relative to the outside at this, local membrane location. And then you see it drops rather dramatically. Well, there are two reasons why it drops. One is because the voltage-gated sodium ions close, okay? Well, they close, and so no more sodium comes in, right? So that's going to, there'll be less positive coming in all of a sudden, so that'll cause that, voltage line to drop. You're starting to repolarize, head towards our resting potential again, right? The other kind of factor that's important is that there's another voltage-gated channel that opens at the threshold potential of minus 55. So you hit minus 55, not only do you get the voltage-gated sodium channel opening and all that sodium rushing in, you actually get the voltage-gated potassium channel opening as well. And the potassium channel stays open for a little bit longer. And watch what happens. You see potassium, this is the GK line, right? It starts to flow out. Remember, it's driven initially by the concentration gradient force because there's so much more potassium on the inside than there is on the outside, right? But as all that sodium comes in, it becomes positive on the inside, and a positive charge relative to the outside. So not only does the concentration gradient force want to kick out that potassium, but so does the electrical force. It's now surrounded by positively charged sodium ions. It wants out. So you see it starts to increase its rate of exit. And as you take a positively charged ion from inside the cell and you send it outside the cell, you're going to be heading in the hyperpolarizing direction, right? You're going to be, repolarizing that neuron, making it more negative on the inside versus the out. And that's why this voltage line drops, and then comes back down here. And this up and then this down kind of pattern is the signature, the sort of voltage signature of an action potential in a neuron.